Okay guys, this is one first of three videos on differentiation methods, chain rule, product rule, and quotient rule. This one in particular is chain rule. These three topics are generally taught together in the old syllabus, they're all in C3. And it's very much a case of they're incredibly practically useful. And I'll do things like, and generally with these videos, I'll do things like proofs in class. I'm giving you the methods as a heads up so you kind of learn them quickly. And then I'll explain why they're true in like more detail when I've actually in front of you. I can take your questions and all that stuff. Okay, so what we do, chain rule. Chain rule is a method of differentiation. The formula is given in the top left hand corner, which probably doesn't make too much sense right now, but we'll go through it. And we use it when we have one function that's inside of another, so like an fg of x situation or gf of x situation. We've got three examples here, and hopefully these will illustrate the point quite nicely. Here we've got 3x plus 7 raised to the power of 11, so that function inside 3x plus 7 is being raised to the power of 11, so that's the thing that's inside. E to the 5x, there we've got e being raised to the power of 5x, 5x is the thing inside the function, of being raised to the power e, and then finally cos has got half x inside of it, alright? Why did I give that definition in that style? Simple reason is it's kind of foundational to how we're going to do this. We're going to call the thing that's inside the other function u. So here we've got 3x plus 7 to the power of 11. The 3x plus 7 is the one that's inside. U is going to be 3x plus 7. Once we've done that, we write y in terms of this new u. So let's have a look at the first example, 3x plus 7 to the 11. If we say that u is going to be 3x plus 7, then y stops being 3x plus 7 to the 11. It's now u to the power of 11. Differentiate both u and the new version of y. To differentiate u, so 3x plus 7 differentiate is just 3x. Differential of y is dy du, and that's just going to be 11u to the 10. Multiply those two things together, and you get your final answer. So we're going to get 3 times 11 is 33, u to the power of 10. But I know what u is. U is 3x plus 7, so 33, 3x plus 7 to the power of 10. We need to do that last step because the answer we're looking for is in terms of dy dx. So if we do it this way, we've eliminated all u's and we get our final answer in the variables that we started with, which is a quite nice result. The formula is given explicitly, as I said, in the top left-hand corner. I want to go through two more examples before we go. Here we've got that u is going to be 5x. Differentiate that, you get 5. Y is now e to the power of u, and we know that e to the power of anything differentiates just down to being e to the power itself, as long as it's just the sole letter without any coefficients. So e to the u differentiated is just e to the u. Multiply those together, you get 5e to the u, which is 5e to the 5x. Last one. Let's say u is a half x, because that's what's inside the cos. Differentiate that, you're going to get a half. Differentiate cos, you get minus sign. We have discussed this, but not properly, and I know there needs to be a video on it, and it will happen soonish. Differential of cos is minus sine. Multiply them together, you get minus a half sine u, which is minus a half sine a half x. That's how it works. The thing about this one is you just need to do tons of practice, and if you want practice, just drop me an email or something. That's that.